Before the mighty T-Rex roamed the land, before the long-necked Brachiosaurus grazed on ancient forests, before any dinosaur ever took its first breath, Earth was already billions of years old, and the story of what came before. It's stranger, more violent, and more incredible than you could ever imagine. This is the story of Earth before the dinosaurs. Our story begins 4.6 billion years ago. Earth doesn't exist yet, just a swirling cloud of dust and gas orbiting a newborn sun. Slowly, particles collide and stick together. Gravity pulls more and more material inward. But Earth's birth is violent. Planetesimals, chunks of rock the size of mountains and cities, smash into each other at incredible speeds. Each impact releases tremendous energy, melting rock and creating a world of liquid magma. This is Earth 4.5 billion years ago. A molten hellscape with oceans of lava, surface temperatures exceeding 1,200 degrees Celsius, and an atmosphere of vaporized rock. If you could stand here, which you absolutely couldn't, you'd be instantly vaporized, then catastrophe. A Mars-sized planet called Theia slams into Earth in the most violent event in our planet's history. The impact is so powerful that debris is ejected into orbit. That debris, it becomes our moon. This collision completely melts Earth's surface once again, resetting the clock on our planet's formation. Over millions of years, Earth begins to cool. The surface hardens into the first solid crust, the beginning of what we'd recognize as rock. But Earth is still an alien world. Volcanoes erupt constantly, releasing gases, water vapor, carbon dioxide, nitrogen, and other chemicals. Meanwhile, comets and asteroids, those icy travelers from the outer solar system, rain down on Earth, delivering even more water. Around 4 billion years ago, Earth finally cools enough for something magical to happen. Water vapor in the atmosphere condenses. It begins to rain, and it doesn't stop. For potentially thousands of years, it rains, and rains, and rains. The first ocean forms. But this isn't the beautiful blue ocean you know. It's likely greenish or brown, filled with dissolved iron and other minerals. The sky above is orange or reddish. There's no oxygen yet. And this ocean is hot, possibly near boiling in places. Earth is still being bombarded by asteroids. This period, called the Late Heavy Bombardment, sees massive impacts that could vaporize entire sections of the ocean. Any life trying to form would be repeatedly sterilized. Yet somehow, in this chaos, something extraordinary is about to happen. Deep beneath the waves, around hydrothermal vents where superheated, chemical-rich water pours from the seafloor, chemistry becomes biology. The first life emerges. We're not sure exactly how it happened, but by 3.8 billion years ago, perhaps earlier, the first single-celled organisms exist. They're simpler than any bacteria alive today, just molecules wrapped in a membrane, able to copy themselves. For hundreds of millions of years, this is all life is. Single cells floating in the ocean, feeding on chemicals from volcanic vents. Earth's continents are small, the ocean covers almost everything, and the sky is still orange and lifeless. Then, around 3.5 billion years ago, something new appears. Stromatolites. These aren't individual creatures. They're massive colonies of bacteria called cyanobacteria, layered together in dome-shaped structures. And these cyanobacteria have a superpower. They can perform photosynthesis, using sunlight to convert carbon dioxide and water into energy, releasing oxygen as waste. At first, this oxygen doesn't accumulate in the atmosphere. It immediately reacts with iron dissolved in the ocean, creating rust that sinks to the seafloor. This creates the banded iron formations we still find today, layers of red and black rock, a record of Earth's sentient rust. For a billion years, cyanobacteria spread across Earth's oceans, pumping out oxygen. And then around 2.4 billion years ago, all that iron in the ocean is finally used up. Oxygen begins entering the atmosphere. This event, called the Great Oxidation Event, is the most significant change in Earth's history. The sky begins to turn from orange to blue. But for most life on Earth, oxygen is deadly poison. The Great Oxidation Event causes the first mass extinction. Anaerobic organisms, those that can't handle oxygen, die by the billions. And there's another consequence. Oxygen reacts with methane, a powerful greenhouse gas. As methane is destroyed, Earth's temperature plummets. Earth enters what scientists call snowball Earth. Ice sheets spread from the poles all the way to the equator. The entire planet becomes a frozen ball of ice and snow, with temperatures dropping to minus 50 degrees Celsius. Life survives only in small pockets, near volcanic vents in the deep ocean. For millions of years, Earth is frozen, dead, silent. But volcanoes keep erupting, releasing carbon dioxide. With no rain to wash away, CO2 builds up over millions of years. Finally, the greenhouse effect kicks in. Earth begins to thaw. But life remains simple for another billion years. Just single-celled organisms floating in the ocean. Then, around 1.5 billion years ago, something revolutionary happens. One cell swallows another, but doesn't digest it. They form a partnership. This creates the first complex cell, a eukaryote. It has a nucleus, mitochondria for energy, and eventually other specialized parts. This is the ancestor of all complex life, every plant, animal, and fungus. Around 800 million years ago, these cells start sticking together. The first multicellular organisms emerge, simple sponges and blob-like creatures. By 600 million years ago, Earth's oceans host the Ediacaran biota, bizarre creatures that look like quilted mattresses, discs, and fronds. They're unlike anything alive today. No mouths, no eyes, no obvious way to move. They simply sit on the seafloor, absorbing nutrients from the water. Earth is still strange, still alien. 541 million years ago, everything changes. In a geological blink of an eye, just 20 to 25 million years, life explodes in diversity. This is the Cambrian explosion. Suddenly, the oceans are filled with animals that have eyes, mouths, legs, shells, and predators. The evolutionary arms race begins. Meet Anomalocaris, the apex predator of its time, up to a meter long, with compound eyes and grasping claws. It's hunting smaller creatures. Here's Opabinia, with 5 eyes and a trunk-like proboscis with a claw at the end. And Hallucigenia, so weird that scientists initially couldn't figure out which end was which side was up, or how it even moved. Trilobites appear, hard-shelled arthropods that will dominate the oceans for the next 270 million years. They have compound eyes, jointed legs, and come in thousands of species. This is when animals first develop hard shells and skeletons, which is why we suddenly have so many fossils from this period. Before this, most creatures were soft-bodied and rarely preserved. But while the oceans teem with life, the land is still completely barren. Just rock, sand, and silence. No plants, no animals, nothing. Around 470 million years ago, the first plants creep on a land. They're tiny, just a few centimeters tall, similar to motomosses. They cling to the edges of ponds and streams. Over millions of years, they spread. They evolve roots to anchor themselves, develop vascular systems to transport water, and grow taller to compete for sunlight. By 385 million years ago, the first forests appear. But these aren't forests as we know them. The trees look alien, some with bark-like scales, others with strange geometric patterns. Animals follow. Millipedes, scorpions, and other arthropods crawl from the sea onto land. At first, they stay close to water, but gradually they venture further inland. Around 375 million years ago, fish begin experimenting with land. Creatures like Tiktaalik have both gills and lungs, both fins and limb-like appendages. The first amphibians evolve. They still need water to reproduce, but they can hunt on land. Earth has its first 4-legged land animals, the tetrapods. Welcome to the Carboniferous period, 360 to 300 million years ago. Earth is covered in vast swamp forests filled with giant club mosses, horsetails, and early trees. The climate is hot and humid across most of the planet. These forests are so productive that they can't fully decompose when they die. Bacteria and fungi haven't yet evolved to break down lignin, the tough material in wood. Instead, dead trees pile up in swamps and get buried. Over millions of years, they'll be compressed into the coal we mine today. The Carboniferous period is literally creating the coal deposits that powered the Industrial Revolution. All these plants pump oxygen into the atmosphere. Oxygen levels spike to 35%, compared to 21% today. And in this oxygen-rich atmosphere, something incredible happens. Insects grow to gigantic sizes. Meganeura, a dragonfly relative, has a wingspan of 70 centimeters, nearly 3 feet across. Arthropleura, a millipede, grows to over 2 meters long as a car. It's the largest land invertebrate that ever existed. The forests crawl with creatures that would terrify us today. But there are no dinosaurs yet. The dominant land animals are early reptiles and amphibians. By 252 million years ago, Earth is thriving. The oceans are full of fish, sharks, and strange swimming reptiles. The land has forests, deserts, and mountains. Reptiles have evolved and diversified. Then disaster strikes. In what is now Siberia, massive volcanic eruptions begin. But these aren't ordinary volcanoes. This is the Siberian Traps, one of the largest volcanic events in Earth's history. For possibly a million years, lava floods out, covering an area the size of the continental United States. The eruptions release massive amounts of carbon dioxide, sulfur dioxide, and toxic gases. The atmosphere fills with ash. Acid rain falls. Temperatures spike. The oceans absorb so much CO2 that they become acidic. Oxygen levels in the water drop. Dead zones spread. 0.96% of all marine species go extinct. 70% of land species disappear. Trilobites, which survived for 270 million years, are completely wiped out. Entire ecosystems collapse. This is the Permian-Triassic extinction event, the Great Dying, the worst mass extinction in Earth's history. Life comes closer to complete annihilation than at any other time. But life is resilient. In the aftermath of the Great Dying, survivors begin to recover. It takes millions of years, but gradually ecosystems rebuild. New groups of reptiles emerge. The archosaurs, ancestors of both crocodiles and dinosaurs, begin to diversify. They're still small, quick, and unremarkable. Small mammal-like reptiles called cynodonts also survive. These will eventually give rise to true mammals, but that's still millions of years away. By 230 million years ago, Earth has recovered. Forests grow again. The climate is warm. The supercontinent Pangaea is still intact, with all the land masses connected. And then, around 230 to 240 million years ago, the first dinosaurs appear. They're small, some no bigger than chickens. Bipedal, quick, unremarkable. They're not yet the dominant animals. They share the world with many other reptiles. But they have advantages: upright posture, efficient breathing, perhaps warm-bloodedness. Another mass extinction around 201 million years ago wipes out many of their competitors. And in the aftermath, dinosaurs finally get their chance. They grow larger. They diversify. They spread across every continent. The age of dinosaurs has begun. From a molten hellscape to a frozen snowball. From the first single-celled organisms to complex life. From barren rock to lush forests. From the worst extinction event ever to the rise of the dinosaurs. Earth's journey to the age of dinosaurs took over 4 billion years. It was a story of catastrophe and recovery, of innovation and extinction, of life finding a way against impossible odds. The dinosaurs would rule for 165 million years before their own extinction. And from their ashes, mammals, our ancestors, would rise to take their place. But none of us would be here without those 4 billion years of preparation. The Earth before dinosaurs was stranger, more violent, and more incredible than we ever imagined. Thanks for watching. If you enjoyed this journey through deep time, please like, subscribe, and let me know in the comments what period of Earth's history fascinates you the most.